Welcome to the second part of Lecture 7, Clustering with R. In the first lecture, we did some exploratory data analysis on the iris dataset. Now we are going to start doing a clustering on the dataset. We are going to load the AP cluster package. We are going to first install it by install.packages AP cluster. Then we are going to load the package. If I say install packages, don't forget the S, AP cluster with a double quote. It's going to go and initiate a transaction against the internet to the CRAN website and download the AP cluster package. And if you notice that it is going through the process downloading the package. Now after the package is downloaded, what we need to load the library so that we can use it. Then we can say library AP cluster. At any point in time, now I can say library now the library is loaded. As I said, at any point of time you can ask for help, question mark AP cluster. You are going to get help on the clustering. I'm not going to you can make this as big as you want, as the size of the screen, but anyway, this is what you will get. Also, as I said, if you say vignette AP cluster, it will launch the PDF for the user guide. We want to use the distribution. There is a function, it's named dist, but we are not going to use it. However, the negative distance matrix is NEG. This matrix stands for negative distance matrix. It will take the distance function, square it, and then multiply it by minus. Now what we are going to do, we are going to create something. I'm going to call it a sim, which is just an object. I'm calling it sim. We are going to call a function. Its name is negative distance matrix. We are going to call it on the irises. If you remember, when we have a square parentheses here, it tells me the rows and the columns. When I leave the rows empty, it means all the rows, and I'm going to use columns 1 through 4. Why do I want to use columns 1 through 4 from the irises? Because these are the numerics 1, 2, 3, 4, and the last one is the classification. I'm going to leave it aside. I'm not going to use it as part of my clustering. Now if I issue the command negative distance matrix of the irises 1 through 4, I need to use r equal to, because this is going to be used in calculating the distance matrix. It means square the distance matrix. That's what is going to happen. Now if I issue the command here, if I sim is negative distance matrix of iris, 1 through 4, r equal to, it is going to create a distribution matrix. Now if I say sim, you are going to see that there is a similarity matrix, which is basically saying, it truncated it. What it is saying in here, it's got to the end. Let us say this is here. It is the similarity between this and between 6 and 1 is 0.38. After it being squared, you take square root of this, because this has been squared. Remember, this is column 1. This is row 6, column 1. This has been squared and multiplied by minus. Then the similarity is going to be the square root of 0.38, which is approximately 0.6. This is the similarity between record 6 and record 1 is around 0.6. Anyway, we created a similarity matrix. This is as simple as this, negative distribution, and it is on columns 1 through 4. Now I'm going to run the clustering algorithm, and I'm going to call my result as AP iris1, because AP affinity propagation iris, and the iris dataset 1, this is trial number 1. AP iris1, this is going to be the object. It's as simple as this. AP cluster, we take the similarity matrix that was created from here, and I'm saying give me as much details as you can. Now if I run this here, it will take a little bit until the result comes out, because it is doing the clustering on that. Now I have an object, its name is AP iris1. Now now it's finished, I have an object. If I say AP iris1, it's going to tell me that okay, this is the object. AP number of samples, we have 150. It took it 162 iteration, and it gives us some statistics in here. I'm not going to worry about it for now. We have 6 clusters. These 6 clusters, the exemplar, the representative of each cluster is these data points. Data point number 8 is the exemplar for cluster 1. 55 is the exemplar for cluster 2. 139, point number 139, 139, this is the point 139, is the exemplar for cluster number 6. And the clusters are as follows. Cluster 1 has the exemplar point number 8, and these are its members. Cluster number 2, the exemplar is 55. Cluster number 2, the exemplar is 55, which is this point. It means this is the representative of the cluster, and these are the points that are in it, etc. Then the cluster 4, 5, and 6. Basically, and I have an object that contains these clusters right now, and I can interrogate this object for different things. As I said here, if I say APIRS1 or show, I could have said show APIRS1, and I would have got the same result. Like for example, if I say show APIRS1, it will give me basically the same results. Also the same thing, but what it is saying, we have 6 clusters. The exemplars for each one of these clusters are these data points, and the cluster 1 exemplar 8, and these are data points. Cluster 4, the exemplar is 0.106, and it has 1, 2, 3, 4, 5, 6, 7, 8, and 9 records. I can also do STR, which is structure, and it gives me some more information. It is hard to read, but somebody who knows R well, they know exactly what these things mean. Now here is the interesting part. I want to visualize the cluster. I want to plot the clusters. I want to see how they will look like. But also to be able to plot the clusters, I need an x-axis and I need a y-axis. Like plot them against what? I can use the x-axis, the y-axis to be any of the sepal length, sepal width, sepal length, petal length, sepal length, petal width, any combination of these, or any combination of these 4, any combination of 2 of these 4 can be used as the x-axis and the y-axis. For now, let me use the first 2, and I'll show you how to use the rest of them. What do we do here? We just simply we said plot. This is the object APIRS1. It's important to do it this way as matrix, because it needs to see it as a matrix. Just accept it as matrix. Then what did I say here? I said iris take the iris data set, all the rows, and column 1 and 2. Basically I'm saying plot sepal length to be the x-axis, sepal width to be the y-axis, and the x label is the sepal length, the y label is the sepal width, because one is the sepal length and 2 is the sepal width. Now, if you look at it, we have 1, 2, 3, 4, 5, 6 clusters, but how do we know which points belong to which cluster? Now we would like to start analyzing our data. That will be the objective of the next lecture, is how to analyze this data. Let me emphasize in here, it's important that let me get this underlined so that we can see it. It's important to pay attention to what we are doing here. Here I'm saying take the first column to be the x-axis, the second column to be the y-axis. I could have said 1/3, etc. And it's important that to say as matrix in here to be able to do this plotting. And if you look at it, we took the object here. This object knows how to plot itself. We said the x labels are these, the y labels are these. And if you notice in here, this is the exemplar point. Here the square, this is the exemplar point, and the lines are connecting. The points are connected to the exemplar point with the lines here. The exemplar point is the rectangle here, the exemplar point is the rectangle here. And if you notice, like now I have this cluster connected, the points are connected to the exemplar. If you look at this point here, this is one of the data set points, etc. This is one of the data set point, the irises data set points, and this is one. For this point, it looks like the sepal length is a little bit less than 5, and the sepal width is around